Hello, my name is Ivan Sembatia, and I'm currently studying data structure at BYU. In this video, I will be walking through recursive functions that checks whether a given binary tree is a binary search tree or BST. So I'll explain the problem. So the problem at hand is to implement recursive functions that can be determine if a given binary tree is a valid binary search tree. So a binary search tree has the property that for each node, the left subtree contains only values less than the node, and the right subtree contains only values greater than the node. So our task is to ensure that this rule holds for all the nodes in the tree. So my approach to solve this problem involves a recursive function that checks each node in tree. So for each code, I will compare its value against the allowable range. So the minimum and maximum values that the node can take. Initially for the root node, these bounds are set to be maybe the smallest and the largest possible integers values. So I traverse down the tree, so I adjust the bounds for the left and right subtrees. The function will check the following condition. So if a node value is less than the minimum or the greater than the maximum allowed for that node, so it's not a valid BST, and the function returns false. So if maybe the node's value falls within the range, the function will recursively check the left subtree with a new upper bound, and the right subtree with a lower bound. This process ensures that every node in the tree follows the binary search tree property. Yeah, so the base cause and recursive cause explanation. This base of the recursion is when the current node is null. In this case, we return the true because an empty subtree is always a valid BST. So in the recursive case, so we first check if the node value falls within the current range. So if it does not, we recursively call the function for the left and right subtrees, so adjusting the bounds accordingly. So for the left subtree, the upper bound becomes the current node's values, and for the right subtree, so the lower bound becomes the current node's value if any point of the node value violates maybe the allowed range. So the function returns the false, so indicating that the tree is not a BST. Here is the explanation of the functions. So we start by calling the helper function is the BST, which checks whether a node's value falls within the allowed range. So if the node is valid, the function recursively checks the left and right subtrees. This ensures that the binary search tree properties adhere to throughout the tree. So that's my solution to the problem. I hope this explanation was clear and helpful. If you have any question or need further clarification, feel free to leave your comment below. Leave your comment below.